China has successfully landed its first rover on Mars. The Tianwen-1 lander touched the planet's surface after surviving the treacherous descent by parachute. NASA's InSight lander found that a significant amount of water has seeped into Mars's crust, adding another layer to the mystery. Humankind's instruments have mapped the corners of the planet, poked at the gravel underfoot, and sampled the air that wafts across the dusty plains. Scientists have learned much from the data collected and sent back to Earth. The Chinese Mars rover Zhurong adds an exciting twist to the story and history of water on Mars. After landing in southern Utopia Planitia on Mars in May 2021, the now-defunct Zhurong rover went to work exploring the Martian surface, and its latest findings might just change the way we think about the red planet. Bo Wu and a team of researchers from Hong Kong Polytechnic University believe they have found compelling evidence of an ocean shoreline for a massive body of water that once covered Mars's northern lowlands. Water doesn't currently exist on Mars's surface, but it used to. We know this from dramatic dry canyons and river channels seen from orbit, as well as minerals on the surface that only form in liquid water. Around 3 billion years ago, something happened to Mars's atmosphere, and most of the liquid water evaporated. However, some of it may still be underground, safely shielded from harmful solar radiation that bombards the planet's surface. Could those ancient pockets of water contain life? As China's first Mars mission, Tianwen-1 is uniquely ambitious. No nation had ever attempted to send both an orbiter and a rover to Mars on the first try, but China succeeded, making Tianwen-1 a historic victory. Tianwen-1 arrived in Mars orbit as a single spacecraft. Once on Mars, the landing platform extended a ramp, allowing the Zhurong rover to roll gently onto the surface, similar to the way China's Chang'e moon rovers are deployed. Zhurong successfully landed on the red planet on May 14. The rover touched down on Utopia Planitia, the vast Martian plain where NASA's Viking 2 spacecraft landed in the 1970s and the site of a shipbuilding yard in the Star Trek universe. Mars landings are uniquely challenging. They require heat shields, thrusters, and supersonic parachutes. A teeth-gnashing experience that NASA has dubbed the 7 minutes of terror. Before our first probe swung by Mars, scientists thought that the planet could be lush and teeming with life. With their telescopes, early scientists made out canal-like features on the surface that they mistook as artificial structures built by intelligent species. However, after the Mariner 4 probe flew by the red planet during the first Mars mission and snapped pictures of a barren surface, these interpretations were proved wrong. Through these missions, we've learned that Mars is devoid of liquid water. Its rocky surface is pockmarked by impact craters, scraped by strong winds, brushed by slow-moving sand dunes, carved by deep valleys, and punctuated by impressive volcanoes. Mars is also home to the tallest and largest volcano in the solar system, Olympus Mons, which rises 2.5 times as high as Mount Everest at 18.6 miles. The most precise measurement of the volcano's dimensions so far comes from the Mars Global Surveyor in 2004. Although Mars's surface is bone dry as far as scientists can tell, it has water, just not in liquid form. Water is locked away as ice, atmospheric vapor, and atoms embedded in the molecular structure of its minerals. A Martian geologist at Rice University, Kirsten Siebeck, says Mars is a still and quiet place compared to Earth, and it doesn't harbor life as we know it. The planet is like a freeze-dried environment. The conditions allowed Mars's geologic record to be preserved for billions of years. As Mariner 4 flew by Mars, it peered through the gassy sheath and picked up all kinds of information. For one, the atmospheric pressure is only 0.7% of Earth's. The planet's smaller gravity and lack of a magnetic field prevent it from retaining a thick gaseous shell. The atmosphere is so wispy that it doesn't do a good job of trapping heat from the sun to keep the surface warm throughout the day. Mars has an average temperature of -80 degrees Fahrenheit. Given these frigid temperatures and low atmospheric pressures, Mars can't support liquid water. If you were to place a tub of liquid water on the planet, most of it would quickly vaporize into gas, while the rest would succumb to Mars's bitter chill and freeze into ice. Nevertheless, Mars's atmosphere is thick enough to sustain dust storms, and they stir up so frequently that they are a perennial feature of the red planet. Mars once sustained liquid water. In 1971, scientists collected ample evidence that liquid water once flowed on the planet. Mars's topographical features include river runoff channels, carved gullies, eroded impact craters, and mud cracks baked into the ground that give us a hint at a watery past. Moreover, in 2005 the European Space Agency's Mars Express orbiter detected hydrated minerals, rocks containing a telltale mix of hydrogen and oxygen atoms in their crystal structure that could have only formed in the presence of liquid water. Ever since the rover Curiosity landed on Mars in 2012, it has been wandering inside Gale Crater, which was formerly a lake bed. Curiosity has found proof that liquid water once pooled here. In 2014, it photographed sedimentary outcrops with a layered structure. Scientists think these are silt pileups that gushed from a river onto a delta. Although Martian liquid water likely lasted for millions of years, it all but vanished 2 billion to 3 billion years ago. But its presence and persistence implied that long ago, Mars experienced a thicker atmosphere and warmer temperatures. All this points toward an ancient environment suitable for harboring life. On October 5, 2020, a team of scientists announced the discovery of a group of 1-billion-year-old Martian sand dunes in the planet's Valles Marineris region. This rare find of palea dunes led scientists to a second big discovery. Mars's climate, atmospheric pressure, and landscape evolution have remained relatively consistent over the past billion years. Further research showed that beneath the dune surface lies bright material layered beneath a darker top layer called a transitional reflective surface, TRS. This material likely formed in the last 400,000 years and suggests significant changes occurred during that time. It is believed that these dunes formed between 2 million and 400,000 years ago during a period of intense climate fluctuations, a period that mirrors the dramatic ice age experienced by our own planet in the 17th century.